Hey guys, welcome back. My name is Jason, and today we're looking at bypassing brute force protection. We'll be looking at the techniques attackers use to bypass these protection mechanisms and do a technical demonstration to see how they work in practice. Now, you'll be expected to have a basic understanding of how HTTP works, and some experience with a web proxy tool like Burp Suite would be beneficial. We'll be using Burp Suite Pro ourselves for our demonstrations, but you should be able to follow along with the free Burp Suite Pro Community Edition if you'd like to try yourself. So let's look at some of the common brute force protection mechanisms. And firstly, we have account lockout, and this is probably the most well-known protection mechanism. And at a basic level, this is where an attacker will go and brute force a particular user's account. And after a certain amount of failed login attempts, the account is then locked for a particular duration or until the administrator then locks the account. And this can be really effective at preventing attackers from brute forcing particular users' accounts. However, it does open up the application to denial of service vulnerabilities. So, say if the attacker gets a list of valid usernames, they could go through the list of usernames and lock out each account, effectively denying service to all of the users. So that's sort of the only drawback that comes with account lockout. Moving on to rate limiting, and this is where the web application limits the number of requests that are sent from the attacker. So you might see this where a form pops up with a captcha field, and it basically stops automated attacks because you need a human element to go in and complete the captcha. Um, so it basically stops any automated attacks from occurring because they can't complete the captcha. Lastly, we have IP address lockout. So this is where we have, this is similar to account lockout, except for the IP address is locked out instead. So regardless of what accounts you have a failed login attempt for, it will increment a certain counter. And after a certain number of failed login attempts across all accounts, the IP address will then be blocked from making any further login requests to the login form. So let's look at some of the common lockout bypass techniques. Some of these we'll be looking at today, like the X forwarded for header and the login counter reset. So the X forwarded for header is, I guess the concept comes from where you have a web application and you send a request to this web application and you send it for a proxy. The web application will receive the request from the IP address of the proxy. However, it doesn't know what the original IP address was of the web of the client. So the X forwarded for header basically tells the web application what the original IP address was. So when a request is sent for a proxy, the proxy will then add the X forwarded for header to the request, and it will put in what the origin IP address was. So when the web application received the X forwarded for header, it will know where the origin what the original IP address was. Um, this can be bypassed by forging the X44 header. So when you send the request to the web application, you could do the X44 header and put a different IP address in. So it thinks it fools the web application sometimes into thinking that the origin IP address is different for each brute force attempt. So effectively, you can't be locked out because your IP address is is masked by all these other IP addresses. So moving on to proxy IP rotation, and this is really similar to X44, except for instead of the web application locking IP addresses based on the X forwarded for header, it locks out the direct IP address. So if you sent a request for a proxy, it would lock out the proxy IP address itself and not the original IP address of the client sending the request. And proxy IP rotation uh, is therefore useful where you have a number of proxies with different IP addresses and you just send each request for a different proxy, and it basically allows you to mask your IP address because the web application works by blocking the direct IP address rather than the X forwarded for headers IP address. And lastly, we have login counter reset. So this is where we have an application where if you log in, it will reset the counter incrementer. So say if you made 2 failed login attempts and then you logged in successfully the third time, the counter would go from 2 to 0. And this can be effectively used to bypass as a technique, because if you did 2 failed login attempts and then you logged in successfully and you did another 2 brute force attempts, you could effectively never reach that counter threshold. So you could just keep logging in successfully and effectively continue brute forcing as you would normally. So it could be quite useful. So let's jump in quickly with to PortSwigger, and we're going to use these labs to demonstrate some of these bypass techniques. And yeah, let's jump into Burp Suite. So here we are on my Kali machine. We are connected to Burp Suite Pro, and we're on PortSwigger doing the username enumeration via response timing, which has the X44 header bypass exercise in it. So if you want to follow along with this exercise, you can follow the link here, which we'll put in the description. And let's get straight into the lab by clicking here. So here we're on the home page of the lab. If we want to go to the login page, and we can put anything in these fields. So let's do like user pass, and then we'll go to Burp Suite Pro and intercept this request. So intercept on, come out, go to login. So you see it's Burp Suite Pro's intercepted the request. What we want to do is right click and go to intruder, send it to intruder, and we'll head to intruder now. So at the moment we've got 4 fields that are highlighted to be brute forced, but we want to clear that and select the password parameter value as the value you want to brute force. We'll click add, and then if we go to payload, we can then add, for this exercise, we can add any passwords we want, because we're just trying to test the X44 bypass. So I've used the PortSwigger default password list. If I then go to start attack, now after a certain number of attempts, the IP the IP should be blocked from making any further requests or login attempts. So if I just check here, go down. Yeah, we see we've got an error message saying we've made too many incorrect login attempts and we've been locked out for 30 minutes. So how do we bypass this? Let's go back to intruder. So like I said during the introduction slides, we can add in an X44 header. X44 colon, and then we can put any public IP address we want. So let's do 112.112.112.x, and we can mark the X as a value we want to have a list for. So what this is going to do is, for our short list of passwords, we could have possible 254 values here. It will send a different IP address for each password. So that's what we want to do. So let's do the attack type as pitchfork, and what this will do is, for each value here, there'll be a corresponding value here. And if we go to payloads, and we go to list 1, so list 1 needs to be cleared now. What we'll do is we'll add in a number. So what we'll do is we'll do from 1 to 254, and we'll do a step of 1. And then for our second list, we'll go to here, add in our password list, and we should be good to go. So now if we start the attack, every request will have a different IP address, and the web application will take the X44 header as the origin IP address and think that each request is coming from a new IP. And so let's start the attack. So now if we look down at payload 11, and go to the response. I didn't like that. Okay. You see it's invalid username or password. So we've effectively bypassed the limit on the limit on the IP address by using the x44 header. So now we can brute force for as long as we want, just try all the usernames and passwords we want to gain access to the accounts. So moving on to the successful login counter reset exercise, we are using the PortSwigger Broken Brute Force Protection lab to demonstrate this. Let's just go into the lab quickly and check that there is a login. There is a lockout policy. So if we go to A, temp 2, temp 3, and if we do once more, you see there is a lockout policy and we are now locked out for 1 minute. So as it stands, we would not be able to do a brute force on this form just because we'd be locked out after our first 4 tries. So to get around this, what we're going to try and attempt to do is log in as with valid credentials as a valid user, and then try a username and password pair that we want to brute force, and then we want to log in again as the valid user. And what we might find is that the counter resets and we should be able to just brute force as we like. So let's go back to the lab description. And if we look here, we've been given the valid credentials. So it's Wiener as the username and Peter as the password. And it gives you the username of the victim account, which is Carlos. And we've been given a list of potential passwords. If I head into here, see PortSwigger's given me the default list. So if I come back, what I've done is copied that list, and in my terminal, I've put it into a text file called word list. So I'll cut out this word list. You see that we've now got the passwords here, and I've also created a Python script. So if I cut out that Python script, you see we've got a script that creates an alternating list of usernames. So it would be like Peter, Wiener, Carlos, and then create a list of alternating passwords that matches the username list. So Peter, password sort of thing. So if we run this script against the word list, so Python intruder, and then we go word list, we should get a word list. So this is the username list. So you see it's alternating, and we've got a matching password list up here. So if we copy this username list, way too far. Copy it for good measure. Head back to our Firefox. Let's access the lab. If we want to go to login, and what we'll do is we'll capture this request in Burp. So we'll intercept, and we'll go to login. And if I select pass as, if I go to send this to intruder, and we go to intruder, and we clear the positions like before, because we want to add the fields for the user and the password field. So what we're going to do is put our list of alternating usernames in here and the corresponding list of alternating passwords here. And we need to amend the attack type to pitchfork, which will make so for each username, this has a corresponding password. So it'll be Wiener Peter or Carlos potential password instead of the same word here and the same word here, which would be for sniper. So we go to payloads now. You see we've got 2 sets of payload lists. We can do is paste the username list that we copied from our terminal in payload set 1. And if I go to payload set 2 and go back to terminal and copy the password list. What was dodgy doing it? Copying the terminal. I'll go too far. Okay, cool. So if I do that and then copy for good measure, go back to Burp Suite and paste this list in here. So now if we run the attack, we should find that it runs smoothly. So we see that we've got an attempt with Carlos and a potential password, and then we log in with Wiener Peter, the valid credentials, and you see here we've got a 302 redirect, which means that we've logged in successfully. And so the counter resets. So we can basically brute force for as long as we like here. And just to show that, I'll go into the response for this and head down. Should give us a incorrect password. So yeah, it hasn't locked us out.
Sorry, I had to cut there because we had to run some issue with the lab. It was a bug where it just wasn't working properly, so I had to redo the exercise. But everything should be fine up to this point. So if we look at the if we sort the payloads by Carlos, and then have a look down the list, there should be a 302 somewhere. So we've got 302 for Carlos as the username and 987654 as the password. So if I right click and I go to show response in browser, and copy, and then I go to the browser and copy and paste that into the browser here. I should now be logged in as Carlos. Yeah, perfect. So that's how you use that particular protection mechanism bypass.
So on to our last exercise today, and this is more of a bonus exercise. We're going to learn how to use macros to get a bit creative and bypass brute force protection mechanisms. So for this, we're using the PortSwigger 2FA bypass using a brute force attack lab. And for this lab, we've been given the credentials Carlos for the username and password Montoya. And we've been told that we need to brute force the 2FA verification code. So if we jump into the lab and log in, what we'll do is we'll type in username Carlos and password Montoya. If I then intercept this, so we can see the flow and log in. So that looks all right. So we'll forward that. And this seems like the 2FA 2FA page. So if I said forward, we get the 2FA page here. So we don't know what the 4-digit security code is. So if we try to brute force it or do a few attempts, you see we get taken back to the original login page. So if we get logged out every time we try and do two codes and both of them are wrong, how do we brute force that? We would need something that could allow us to log in every two failed attempts and keep logging in to continue doing the two attempts. So what Burp Suite has is something called macros. So what we can do is if we go to project options, go to sessions, at the bottom here we have macros. So what we can do is we can take in some like a flow. So if I take from login to I'll do up to here. I should rotate to get, but so if we do that in macro, so add, and we'll go to the bottom, and we'll take from the get request to login page to the post request to the 2FA page. What we'll do is do OK, and then we can remove the bits we don't need. So these are little PortSwigger bits we don't need. So remove item. Yes. Academy Lab header. Remove that. Yes. So now we have the GET request to get the login page, and then we have the post request to send the login credentials, which are pre-populated, I think, with Carlos's. Yep. And then we have the GET page to get the 2FA page, and then we have the post request to send the 4-digit code. So if we go bottom here, got the code. So what we have to be careful is of the cross-site request forgery token. So if we look here, you see it's sent with a CSRF code. So what we need to do is configure item, and instead of using a preset value, which would basically invalidate it after the first use, we could do derive from prior response. So in the GET response for the login page request, it would have sent a CSRF token, and what the derive from prior response will do, we'll find that CSRF value and put it through into the request for the post here. And we've also got to do the same for this post. So we've got the GET page gets the CSRF code, and then we can pull that through. So instead of the preset value, we'll derive from prior response. And we have our macro. So that's our macro. We need rules. And if we go to scope, for this purpose, because we're only using this exercise, we can include all URLs. So what it's saying is for all URLs, do this rule. So go back to details, and for rule actions for this particular rule, we can add, and we can run a macro. And here we have our macro selected, which is good for us, and we press OK. So what it's going to do is run the macro for whenever we come across all our URLs, and we press OK. So that rule is now active. So what we can do is, if we go to our proxy and take the login to, send to repeater, and send, we can see that we get an OK message, which means the macro is working. Just look for the error code, see incorrect security code, so we can do as much as we want. So if we do another one, you can see it's still here. It's logged us in again, and brought us to the code page. Do it again, and you see we're not being logged out again. Well, we are being logged out, but the macro is logging us back in with each request. So we can continue to be logged in, use a code, log in again, use a code, but it's automated. So what we can do is now send this to intruder, sorry. We go to positions, clear the positions, and what we want to brute force is the code itself. So we can add, and snipe is fine. And for payloads, we can go to number, because we want to generate a number between 4 zeros and 4 nines. Where's the number? And we can do between 0, 0, 0. Oh, but I think it's crashed. Don't die on me. That's fine. So 0, 0, 0, and 9, 9, 9, 9, and the step will be 1. But we need to, if you see here in the examples, it shows that it's not going to end up like we want. So we need to put in minimum integers of 4, and we could put max integers of 4 as well. and you see that it now comes with the format we want. And we've got to be careful because we need to do one thread just because of the CSRF token. If we do 5, one CSRF token will be valid, and the other 4 won't. So that's why we do one thread. And if we do start attack, we can see that we are getting. Let's have a look just to make sure it's worked. Yeah, so each time we are sending a request for the code. So it's a very slow process. There's probably a better way of doing this, but is that it? Wow, okay, I think we found it already. So what we can do is, it seems like this is the valid, it's got the right code. Lucky that it was 0029. And we can go to show response in browser. So we can copy this and come back to Firefox, open a new tab, and browse there. It's being picked up by the proxy, turn intercept off, and you can see that we should be logged in as Carlos. So that's a lot to take in. It's definitely something to play around with, and definitely have a go at this yourself. Yeah, that's basically how you can use macros to get creative and be a bit more complex in how you try and solve these exercises, in how you solve a bypass of protection mechanisms.
So thank you for watching. I hope you found the video insightful. We did run into a few bugs during the video, so I had to go back and re-record a couple of times, but we got there in the end. So yeah, please like this video if you found it useful, and if you'd like more content, please subscribe for updates. But yeah, my name's Jason, and I wish you all a great day. Goodbye.